AISL, October 2023, Time Zone 1, Paper 1. Question 1. We are given data for G and T, and we need to find the regression line of T on G. We simply input the data into the calculator and obtain the regression equation. The Pearson's correlation coefficient R is 0.994, which shows a very strong positive correlation. For part B, we are told that G equals 13, and we want to find T. So, we substitute G equals 13 into the regression equation and get T equals 13.5. Now, we are told that T equals 22, and we need to explain why it is inappropriate to use the regression line to estimate G. This is because the regression line is T on G, which means it is designed to predict T from G, but not the other way around. Using it to predict G from T would be inappropriate. Question 2. We are given a new unit of length called REC. 1 to 2 decimal places, 1 REC equals 0.52 meters. We need to write down the upper and lower bounds of 1 REC in meters. The upper bound is 0.52 plus 0.005, which comes from half of the rounding unit. 0.01 divided by 2. The lower bound is 0.52 minus 0.005. For part B, we have a permanent with a square base. The sine length is 440 REC and the height is 280 REC. We need to find the minimum possible volume in cubic meters. To do this, we apply the formula for the volume of a pyramid, which is 1/3 times the base area times the height. The minimum volume occurs when both the base and the height take their lower bound values. So we multiply 1/3 by the base sine 440 times the lower bound 0.515 squared, and then multiply by the height 280 times 0.515. Question 3. We are given a function f and we want to find its vertical asymptote. To do this, we look for the value of x that makes the function undefined. Since there is an x in the denominator, the function is undefined when x equals 0. Therefore, the vertical asymptote is x equals 0. Next, we need to find the derivative of f of x. First, we write f in the form of a sum of the terms with powers of x. Then, we apply the power rule to differentiate each term and obtain the expression. For part C, we want to find where f of x is increasing. This means we set the derivative greater than 0 and solve the inequality. Question 4. We have a Von Neumann diagram with points A, B, and C. The boundaries of the regions are shown by the dotted line on diagram 1. First, we want to find the point where the boundaries meet. To do that, we simply identify and write down the coordinates of the intersection point. For part B, we need to find the perpendicular bisector of line AC. We start by finding the slope of line AC and take this negative reciprocal to get the slope of the perpendicular bisector. Next, we write the equation of the bisector with unknown y-intercept. By substituting the coordinates of the point we find in part A, we can calculate the y-intercept, and hence the full equation of the perpendicular bisector. For part C, we are given another point D, and the new boundaries of the Von Neumann diagram are shown in diagram 2. We need to find the vertex that is farthest from point D. To do this, we calculate the distance from D to each vertex using the distance formula and compare the values. The point with the greatest distance is the one we are looking for, and the distance is 7.59. Question 5. We have a diagram with bearings, and we want to find angle RST. By considering all the north lines are parallel, we can see that this angle is 60 degrees. Therefore, angle RST is 98 degrees. Next, we are told that point T is directly east of point R. So, we can draw a horizontal line connecting R and T. Then, we can easily find that this angle is 30 degrees, and this one is 52 degrees. With these angles, we can apply the sine rule to find the length of RT. Question 6. We are given a function h, and we need to find h inverse of 1. For this question, there are two possible ways to do it. We can first find the inverse function of h, or we can take a shorter approach. Since the input of h inverse corresponds to the output of h, we can simply set h of x equal to 1 and solve for x. Doing that, we find x equals 17. For part B, we need to find the domain of the inverse of h. The domain of the inverse is the same as the range of the original function h. Therefore, the domain is x greater than 1/2. Question 7. We have a quadratic function, and we know that it passes through the 3 points shown here. For part A, we use the first point to form an equation in terms of A, B, and C by substituting the coordinates of that point into the function. For part B, we do the same with the other 2 points. Substitute them into the function to form 2 more equations. Now, we have a system of 3 simultaneous equations. Solving this system allows us to find the values of A, B, and C. For part C, here is a wall that is 1.8 meters high and located 30 meters from the origin. We need to show that the ball passes over the wall. That means we calculate f of 30 and check if it is greater than 1.8. Substituting the value, we find f of 30 equals 2.01, which is greater than 1.8. So, the ball passes the wall. For part D, we want to know how far the ball will travel from the origin until it hits the ground. This happens when the height is 0. So, we set f of x equal to 0 and solve the quadratic equation. The distance traveled is the positive solution. Question 8. We have a function r of x and point h has coordinates -2 and 16. For part A, we need to find r prime of -2 using the calculator. For part B, we need to find the equation of the normal to r of x at point h. We are told that the slope of the tangent at this point is -14. Therefore, the slope of the normal is the negative reciprocal of that, which is 1/14. We can write the equation of the normal as y equals 1/14 x plus c. By substituting the coordinates of point h into the equation, we can find the value of c and therefore the full equation of the normal line. For part C, we need to find the length of the bridge GH. To do this, we find point G by calculating the intersection of the normal line with the curve r of x. Once we have found both coordinates of G and H, we use the distance formula to find GH. The result is 5.55. Question 9, Part A. There are 4 statements, and 2 of them must be true. We need to find out which 2 are correct. The first statement says class A is normally distributed. However, This is not mentioned anywhere in the question, so it may not be true. The second statement says there is a higher percentage of students in Class A who received a grade less than 70 on the exam compared to Class B. Looking at the box and whisker diagram, the lower quartile of Class A is below 70, but the lower quartile of Class B is above 70. Therefore, more than 25% of students in Class A receive grades less than 70, while that is not true for Class B. So, this statement is true. The third statement says more students in Class B received grades greater than 90 on the exam than in Class A. We can see that a score of 90 is higher than the upper quartile of both classes, but still lower than the maximum for both. Therefore, we cannot determine whether this statement is true or false. The fourth statement says that the interquartile range for Class A is greater than that for Class B. From the diagram, the box for Class A is clearly wider than that of Class B, meaning its interquartile range is larger, so this statement is true. Next, we are given data for Class A and Class B with values from 1 to 10. It is believed that there is no difference in general values between the two classes. Assuming that both sets of data can be modeled by a normal distribution, we conduct a t-test with a 5% significance level. Let mu1 represent the mean of Class A and mu2 represent the mean of Class B. The new hypothesis is mu1 equals mu2, and the alternative hypothesis is that mu1 is not equal to mu2. Part C. The p-value can be found by entering the data into the calculator. Part D. We find the p-value is greater than 0.05, so we cannot reject the new hypothesis. Question 10. We roll a dice, and getting a 5 or a 6 means winning a prize. If we don't get a 5 or 6, then we flip a coin. If the coin lands on heads, we still win the prize. So we can complete the tree diagram. The probability of rolling a 5 or 6 is 1/3, and the probability of not getting a 5 or 6 is 2/3. For the coin flip, the probability of heads and tails is both 1/2. The probability of not winning the prize is the probability of not rolling a 5 or 6, which is 2/3, multiplied by the probability of getting tails, which is 1/2. That gives a final answer of 1/3. Finally, we are told that a prize has already been won, and we want to find the probability that it was from rolling a 5 or 6 on the dice. By using the conditional probability formula, there is the probability of getting a 5 or 6 divided by the probability of winning a prize. So that is 1/3 divided by 1/3 plus 1/3, which equals a half. Question 11. There are 5 working days in a week. A girl drives to work, and the probability that her car works on a given day is 0.72. Let x be the number of days her car works. Then x follows a binomial distribution with n equals 5 and p equals 0.72. Part A. We need to find the probability that x equals 3. This can be calculated directly using the calculator's binomial probability function. Part B. She walks to work when her car doesn't work and it is not raining. And she takes the bus when the car doesn't work and it is raining. We know that the probability of rain is 0.42. We want to find the probability that she doesn't have to take the bus on any of the 5 working days. First, we find the probability that she takes the bus on a given day. That happens when the car doesn't work and it rings. So, it is 1 minus 0.72 times 0.42, which equals 0.1176. Let y be the number of days she takes the bus. Then, y follows a binomial distribution with n equals 5 and p equals 0.1176. The probability that she does not take the bus at all in the week is 1 minus 0.1176 to the power of 5. Question 12. We have two sets of data, and we want to find the Spearman's rank correlation coefficient. First, we complete the table of ranks below. To do this, we arrange the data in the second set in order, from the highest score to the lowest, and assign the ranks accordingly. Once the ranking is complete, we calculate RS by inputting the data into the calculator. Next, we perform a hypothesis test at a 10% significance level. The new hypothesis is that there is no monotonic relationship between the two sets of data. The alternative hypothesis is that there is a positive monotonic relationship. We are given that the critical value of RS is 0.643. Finally, we compare our calculated value of RS with the critical value. Since the RS we obtained is lower than 0.643, we cannot reject the new hypothesis.